My project's aim is to design and implement a user-friendly medical database web application that will produce and monitor medical records in a GP practice. So patients will enter their health data, and AI will determine if the health data is normal, low, or high, and the AI will also predict future readings. So the potential key stakeholders for my project are admin, GP, and patient, and their primary stakeholders because they interact with the system. For the supporting and secondary stakeholders, it's IT support and system manager and owner because they oversee the system. And for the wide environment, it's developers, NHS, and GDPR because they can set rules and guidelines, and the developers are the creators of the system. And for a negative stakeholder, I've identified a hacker. So the primary stakeholders are the users that interact with the system, and that is GP, admin, and patient. And for the secondary and supporting stakeholders, it's IT support, system owner, NHS, GDPR, and developer. So the IT support maintains this application, the system owner overviews the application, GDPR and NHS, they ensure rules and standards are met, and GDPR ensures that data protection standards are held, and the developers are the people who created and designed the application. So from my document analysis, it shows that 79% of patients had concerns over if their medical records were to be stored as an electronic health record. This was due to security issues. It was highlighted that the establishment needs to provide suitable privacy and security measures to change this mindset, and that was from a patient stakeholder. So this influenced my system because I added a role-based system to my application and restricted access depending on user. And secondly, for a patient stakeholder, I found that AI is becoming an option to use with patients and can provide tailored intervention. Furthermore, AI-based messages and alerts can support patients when required. And this influenced my system because AI is becoming popular in healthcare and can support patients with treatment. So I added AI analysis into my application. And thirdly, from findings, applications that do not have good usability will not be used by users regularly. This highlights that applications need to be accessible so users can engage with it daily. So this influenced my system because I aim to add a user interface that has good usability and is accessible to all groups. So for the GP stakeholder, I found out that GP practices are increasingly working together, but there's the argument that there needs to be increased understanding of how digital medical records operate. And because of this, I added role-based access that limit what different users can access, and email of a user needs to be validated before user can register. As GPs have a higher workload, electronic decision tools are seen as an ideal tool to manage health issues, and it's found that if these tools are and it's found that if these tools work well with medical record systems, GPs find them helpful. So this is why I did AI analysis to manage chronic conditions. And this is done by the AI analyzing the patient's health reading and predicting future health readings. So for the NHS website, I found out that different users have different roles within the system. So the admin can view and remove records, and healthcare professionals also have access to these records. So this influenced my system because I added different users to manage and use the system according to their role. Certain users will not be able to carry out certain actions. And for the admin stakeholder, studies have shown that medical records sometimes have issues with protecting patient data, and this is not due to providing users with access at the time. And this causes issues because it can lead users to log in with other members' login credentials, allowing them to obtain data that they do not have normal access to. So because of this, it influenced my system to not allow users access with invalid credentials. For also email validation, the user's email needs to be validated before they can register and use the system, and role-based access will be used. From the survey results of 10 questions to volunteers, I gathered these results. So 50% of volunteers agreed that a secure web medical records database would give them peace of mind regarding their patient health data. 87% of people already had a medical record system online. So 37% of people people disagreed that the current medical systems are user-friendly and accessible for all age groups. And 50% thought that visual aids such as charts and lists will support their understanding of their health data. And 50% agree that adding AI to health data and alerting them if a reading was out of range was helpful. And 37% either agreed or were neutral on using AI on the historical readings to predict future readings to help manage chronic health conditions. %50 thought that it would be helpful if a GP would be alerted immediately of a dangerous reading level for chronic conditions. And 75% thought it would be beneficial to receive tailored feedback from the GP on the manage. 75% strongly agreed that receiving tailored feedback from the GP would be beneficial to manage chronic conditions or future ones. 50% thought that having role-based access to the medical records database would provide them peace of mind. So for my functional and non-functional requirements, I've already done the medical records should be created and stored, and user access will be denied with invalid login credentials. So for the use case diagrams, it shows the actions of each user in the system. So the patient can view medical records, input the data, the AI will analyze the health data, view the patient medical record, and view GP feedback. For the admin, they can manage users, assign user roles, and create and store medical records. And for the GP, they can update medical records, view patient health data, and provide patient feedback. So for the overall system, the users interact with the user interface, and that's made of HTML, CSS, and JavaScript. And for the backend, it's a Django web framework in Python that communicates with the Django models database. And the AI analyzes the health data inputted by patient, and then it determines the status of a reading, low, normal, high, or dangerous, and also predicts future health readings. So the activity diagrams for normal reading shows the patient logging the health data, and the data gets added to a database. The AI analyzes the reading, then it decides normal, high, or low. Then the readings are provided to the GP. Then the GP views the health data of a patient, adds feedback. The GP feedback gets stored in the system, and the patient views the GP feedback. So for dangerous health reading, the health data is submitted, and it gets added to the system, so the database. So the reading then goes through a decision. So if the health data is not dangerous, the AI decides normal, high, or low for the reading. But if it's dangerous, an app notification gets sent to the GP. The GP views the notification, adds the feedback, Then the feedback is stored and the patient views the feedback. But if the reading is normal, the reading status is shown to the patient on their dashboard. So for admin creating medical records, they enter the details, and if the details are invalid, they're denied access, and if they're valid, they can access the admin user interface. So if the details are valid, they get access to the admin user interface. Then they can create medical records, add the patient and GP to that medical record, and if the details are valid, it gets saved to a medical database. If it's not, it shows that there's fields that need to be filled out, and the missing information is added to the field. Then when the medical records are added, it's confirmed. It gets saved to the database. So for user registration, the verification, because the account is unverified, a verification email is sent to the user. They receive a code that verifies their details, and if the details are valid, the account is verified. If it's not, details will not be verified. For the view patient record, the patient logs into the system, the details are verified, and if the details are correct, they get sent to the patient user interface. They can view the medical record, and they retrieve the medical record details from the database, and the database stores the patient record for the patient. A GP updated medical record, so when the details are confirmed, they log in the user, they search for the patient, the GP, they view the medical record, the system retrieves the medical record details, the GP updates the medical records, and the medical records updated details are saved into the database. So for the wireframes, login and register, it will be the same for all three users, admin, GP, and patient. So they can, in login, reset their password, and in register they can add their details. So for the patient medical record, on the medical records page, it would show the patient's detail, the assigned GP, and the medical records notes. And for the reading dashboard for the patient, it would display their readings and a chart which would show their readings visually and the predictions of their future readings, and the GP's feedback, the AI status, so if a reading is high, normal, or low, and the value of a reading, so glucose levels or blood pressure. and the reading type would show if it's either glucose or blood pressure. And for the admin, on managed users, it would show admin, GP, or new patient. And down below it would show current users, and the admin can edit or delete users. And the admin can also create medical records. So for the create medical records, the admin can create a patient and a GP and add medical records notes and add the medical record to the system. So for updating medical records, the GP can search for a patient in this wireframe. They can display the patient record and update the medical record and save changes. On the GP homepage, there would be a notification, and those notifications would display when a patient's glucose or blood pressure level is dangerous. So for the view patient, it would show the patient's the reading status and the GP feedback. So it'd be a list of patients that the GP can search for. So for my updated timeline, I've delayed the UI development until the last week of March, and the build complete of the AI. And for ensure all requirements, I've updated the time frame because of the delay in the other tasks. Overall, the primary stakeholders who use the system are GP, admin, and patient, while the secondary and supporting stakeholders ensure rules, standards, and data protection are met. The functional and non-functional requirements were listed and was shown what was already achieved and what is pending. The use case diagrams show the user actions in the system and how each user has different roles. The activity diagram showed different processes for different activities. Frames showed how the UI and the wireframe showed how the UI interface will look like. Thank you.